Hello folks, we come to the miscellaneous exercise and this is our part 1 video. Let us, the first two problems they ask us to find out the values and then later on it is like prove that. So let's find the value. We all know that the moment you have to find a value, you have to check whether the angle is in the principal branch. If it's not in the principal branch, we use our trigonometric concepts and get it in the principal branch, then try to get the value. So same problem is there over here. It's a cos inverse thing, but it is 13 pi by 6 and we know that our principal branch for cos inverse is between 0 and pi. So it's not there in the principal branch, we have to get it in the principal branch. Let's see how we can get it. Cos inverse of cos 13 pi by 6 is no harm if we call it as 2 pi plus pi by 6. Why? Because if we equalize into 6 into 6, then this will become 12 pi plus pi, 13 pi by 6. We can call it as 2 pi plus. Now when we call it as 2 pi plus theta, it is lying in the first quadrant, and in the first quadrant everything is positive. So as a result, this will become cos inverse of cos pi by 6 because it is in the first quadrant. Now it is in the principal branch, so the value becomes pi by 6. That's it. The value is pi by 6. Same way now tan 7 pi by 6, the principal branch is between minus pi by 2 and pi by 2. So this is not lying there. It is a value more than pi. So that is why we have to get it in the branch, and let's see how it is going to work. Tan inverse of, instead of telling 7 pi by 6 is no harm if we call it as pi plus pi by 6. When we equalize into 6 into 6, it will become 7 pi by 6. So pi plus something means it's the third quadrant, which is a quadrant for tan itself. So there is no harm in writing tan pi by 6. Tan inverse of tan pi by 6 therefore is going to be pi by 6. Because they are opposite operations, they are inverses of each other. So it comes to identity. That's how it is. Tan inverse of tan, they are inverse operations of each other. So when they are composed together, they give you identity function. So you get back pi by 6. So that's about this. These were the problems where you have to find the value. Now remaining two problems. Quite a few problems you are doing proof that. So this you have to prove. Left hand side equal to right hand side. Let's get right away. We will first consider the LHS and we'll consider the right triangle. How is our right triangle? It has got sides 3, 5, theta, because it's a triplet, it's 4. You know that sine theta here is 3 by 5, which makes theta as sine inverse of 3 by 5. And we are always interested in tan, because tan is a very flexible function. So tan theta is 3 by 4, that way tan theta is also tan inverse of 3 by 4. Now LHS. We could have, we don't want to consider LHS earlier, yeah, because we are, yeah, I think this looks much better. Yeah, now LHS is 2 sine inverse of 3 by 5, which is for us theta, and theta for us is tan inverse of 3 by 4, right? So 2 tan inverse of 3 by 4. 2 tan inverse of theta, we've learned the property. What is the property? 2 tan inverse of theta has a property that it is tan inverse of 2 theta by 1 plus theta square. Right. So let's come back to that property and let's see how that works. Tan inverse of minus. Yeah. So tan inverse of 2 into 3 by 4 by 1 minus 3 by 4 the whole square. So let's see what happens. This will come to tan inverse of 3 by 2 by 1 minus 9 by 16, right? We can have it equalized into 16 into 16. So this will be tan inverse of 3 by 2 by 16 minus 9 by 16. Tan inverse of 3 by 2 by 7 by 16. So tan inverse of 3 by 2, division is multiplication by reciprocal. 2 pizza, so that is tan inverse of 24 by 7. and that is our RHS, and that's how we prove it. Right. So now we move to this problem, and we'll see how we can show the sine inverse of 8 by 7 plus sine inverse of 3 by 5 is tan inverse of 77 by 36. So before we actually start, we'll not do the blunder like we did there. Before we actually start the problem, we will consider the right triangles of the left hand side. Consider the right triangles. 3, 5. Oh, that's unfair because the first one is 8 and 17. So this should be 15. And this is 3, 5, 4. Here. Sine theta is 8 by 17. Theta is sine inverse of 8 by 17, and tan theta is 8 by 15. So theta is tan inverse of 8 by 15. So also sine phi is 3 by 5. Phi is sine inverse of 3 by 5, and tan phi is 3 by 4. Phi is tan inverse of 3 by 4. Consider LHS. In terms of this, the LHS is going to be theta plus phi, isn't it? And theta we know is tan inverse of 8 by 15 plus tan inverse of 3 by 4. Tan inverse of A plus tan inverse of B formula we had. What was the tan inverse of A plus tan inverse of B is tan inverse of A plus B by 1 minus A. So tan inverse of A plus tan inverse of B is tan inverse of A plus B by 1 minus A. Okay. 3 by 4, 1 minus 8 by 15 into 3 by 4. Let's solve this and see what's coming. Tan inverse of, let's have it equalized, into 4 into 15. Yeah, this is in 15 into 4 when we equalize 15 into 4. So 32, 15 3s are 45 by 15 into 4 over 15 into 4 is 60. 60 minus 24 over 15 into 4. That can cut each other. And see this. Tan inverse of 5 and 2, 7. 4 and 3, 7. 60, 10 minus 4, 6. 5 minus 2, 3. Oh my god, such a strange number. Yeah, that's RHS. And hence put. Right, because it goes to right triangles. So that's how we have tried to show that LHS is equal to RHS. With more similar kind of problem will come in the next video. Thank you.